Hello everyone, welcome to mathematics. Remember we are doing statistics 2 and this is lesson number 5. So we have another lesson to finalize this topic. So this is how we are moving. We started at data presentation where we looked at frequency tables, histograms, pie charts, frequency polygon, and we also moved to measures of central tendencies, where we looked at mean, both grouped and ungrouped, median, both grouped and ungrouped. And this lesson we are going to look at mode, both group and ungrouped. And in our last lesson we are going to look at how to calculate range. Now let us look at mode. So mode is also grouped into two. Mode with grouped data and mode with ungrouped data. So let's start looking at mode with ungrouped data. So mode is defined as the most common score in set of scores, or the most appearing number or numbers in the set of scores. So this is how we define mode. The number which is appearing most is defined as the mode. Now let us look at these examples. We have example 1 with that set of scores, and also have example 2 with that set of scores. Let us move on to solutions, how we can solve mode with ungrouped data. So the first question was for us to calculate the mode with those set of scores. So here we just look at the number which is the most appearing. So in this case mode is 6, because 6 is seen appearing 3 times. So we can say our mode is equal to 6. Let us look at the next example, and we also check the most appearing number. So in this case the most appearing number, we have two set of scores. We have 13 and 15. So here mode is equal to 13 and 15. There's no need to find the average here. We don't find average in mode. We just write all the set of scores which have appeared most frequently in our set of scores. So if having 3 numbers which are appearing frequently, we just write 3 numbers, not finding the mean or the average. Here let us look at the mode with grouped data. So let us define the mode with grouped data. So mode in grouped data is the value that has the highest frequency in a data set. So the mode value that has the highest frequency in a data set. So mode with grouped data is the must that you need to find the class mode. So the first thing to do when you want to calculate the mode in grouped data, you need to find the class mode, or also known as the model class. So how to find that model class? So you just check the class which has the highest frequency. So the class with that highest frequency now is your model class. The mode in grouped data can be found by using this formula. So mode is equal to L plus D down 1 over D down 1 plus D down 2 times I, which is the class width. Now let us discuss the terms used in the formula of calculating mode in grouped data. So here is our formula, and L represents lower boundary of the model class. Lower boundary of the model class. Lower boundary of the model class. So after identifying your model class, you need to find the boundaries of model class. So after finding the boundaries of model class, you need to locate. You need to find the value the value of lower boundary of the model class. So in the model class, you need to locate where there is lower boundary of that class. So it will make sense as we are going to deal with the real problems. So we also have D1. So D1 is calculated by frequency of model class. You just locate the model class and go where there's its frequency. Then you subtract with the frequency of the class before. So you indicate, you go where there's that frequency of your model class. Then that value you subtract with the frequency before that model class. So it also makes sense as we are going to discuss in the next slide. Also have the frequency of we also have D2, which can be calculated by frequency of model class minus frequency after that model class. So you just go where there's a frequency of the your model class, and that value you subtract the frequency of the class after the model class. Now we also have the I, which is also the class width of the model class. So your model class here is acting as the direction. So choosing wrongly your model class, it means you have ruined all your work. So here I represents the class width of the model class. So we are also going to discuss that one. Now here is our example. A farmer weighed pigs in his stock and found their masses as in the table below. Then it's asking you to find the mode. So in this case, this data is global data. As you can see, it has the frequencies and the class intervals. Now let us look at the solution. Now you draw your table with 4 columns. So in each column you put information based on your example, like the we have weights. Then you also add the another column of class boundary, and also the class marks, though it's not necessary. Then you also add the table of frequencies. So on the weights, you just copy from the example and you paste the values here. And the class boundaries, as I've already said, you calculate class boundaries by subtracting the lower limit, which is 7. You subtract 0.5. So 7 minus 0.5, you get your lower boundary, which is 6.5. For the upper boundary, you just add 0.5. So the upper limit plus 0.5, you get 9.5. So likewise here, the lower limit is 10, you subtract 0.5, you get 9.5. And for that one, you add 0.5, you get 12.5. And the that for the other class intervals. For class max is the same as midpoint. So you just add the values of the class interval. Like for example, we have 7 and 9, so you add 7 plus 9, then divide by 2. So 7 plus 9 is equal to 16 divided by 2, which is 8. Then you do the same with the list of values. For frequency, you just copy and paste. Now, to choose the class, model class, you just go to the last column of frequency and locate where there is the highest frequency. So our highest frequency is 19. Then you go back to the class interval, which is 16 to 18. So that one is your model class. So model class is 16 to 18, the one with the highest frequency. So in our case, the highest frequency is that one, and its model class is 16 to 18. Now to calculate L is you just go where there is your model class. So your model class is 16 to 18. Then you find the lower the lower boundary. So in 16 to 18, the lower boundary of that interval. So we have 16, so that one is our lower limit. So its lower boundary now is 16 minus 0.5, which is 15.5. So L is equal to 15.5. So that one is our L. Now let us go to D1. So D1 is calculated by by subtracting your the highest frequency minus the frequency before the highest frequency. So the frequency before the highest frequency is 14. So 19 minus 14, that's when you get 5. So to calculate D1, you just subtract the highest frequency minus the frequency before the highest. So 19 minus 14, which is 5. So D1 is 5. To calculate D2, D2 you subtract you subtract the highest frequency with the frequency after that highest frequency. So the highest frequency here is 19. So the frequency after 19 is 7. So those values needs to be subtracted. So 19 minus 7, you are getting 12. Now let us look how to get class width. So for class width, you just locate where there is where your the class class boundaries of the model class. So the model class is 16 to 18, and its class boundary is 15.5 to 18.5. Then what you do there, you just subtract. So the 18.5, you subtract 15.5, as we were doing in previous lessons. So the answer now is 3. So here is our formula. We need just to put our values there. So our L is 15.5, our D1 is 5, our D2 is 12, then our I is 3. Then you continue solving. So 5 over 17. So for 17 is 5 plus 12, which is 17. Then after that, you simplify 5 over 17 times 3 plus 15.5. So here our mode now is 16.3824. So this is how we find mode in globed data. So this marks the end of today's lesson. So in next lesson, which is also our last lesson in statistics 2, we are going to do to calculate range. So please don't miss the next class. Thank you.